Michael Sigmund, and this is Lab 1 Charge Tapes for Professor Berger's Physics 2112 class. The goal of this lab is to determine how two charged objects interact with each other, with charged and neutral objects, and from this determine the amount of excess charge on the tape and the number of missing electrons. So first we need the fundamental principles for this lab, and that would be the electric field and force equations. And the first one is the energy equals 1/4 pi epsilon naught times the charge of the particle divided by r squared. And the second one is the force of the electron equals the charge of the particle times the charge of the other, or the energy of the other particle. And then we need Coulomb's law, which the force equals 1/4 pi epsilon naught times the charge of the first particle, and then times the charge of the other particle divided by r squared. And then finally we have Newton's second law, which is force equals mass times acceleration. We also need some initial assumptions for this lab. The first one is that each piece of tape can be viewed as a point charge. The second one is both pieces of tape obtain the same charge. And then the third is that we can ignore air resistance. And then finally, the tape will always have a weight of 1 gram per meter. So here's some observations I made. The tapes both repelled each other, and both the tapes were attracted to my shirt, which is negatively charged. And the tape was attracted to my hand, which means that my hand is negatively charged. And since both of the tapes were attracted to negatively charged objects, then the tapes were therefore positively charged. So the mass of the tape was 1 × 10⁻⁴ kilograms, and the distance between the tapes were 0.018 meters. And so the gravitational force, to find that, you use Newton's second law, which is mass times acceleration. So the mass times 9.8 which is the gravity acting downward upon it, and then you get 0.00098. So then you plug it into the function for the gravitational force, and to get the charge, which gives you the charge being 3.24 × 10⁻⁹, and the charge of both tapes would be the same. And then to find the number of electrons, you just divide that by the charge of the electron, which would give you 2.025 × 10⁻⁻10 electrons on each piece of tape. So this is when I run my code. You can see the two balls would each represent a piece of tape, and the arrow going down on the tape on the top is the gravitational force, and the arrow pushing up is the electric force. And you can see that the vectors are basically the same lengths, which means that it's an equilibrium. And you can also see that the charge of the tape and the missing electrons are very similar to the values I got from my experiment. So the what if question for the lab is, what if electrons had positive charges and the protons had a negative charge? What would change about the observations you made with the tape and other charged objects? So if the charge were switched, nothing would change. The objects that attracted would still attract, and the objects that were repelled would still repel, because they would still remain opposites to the objects that they were before, or they still remain the same charge. And finally, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? So because our hands are negatively charged, they would attract the electrons on our hands and cause the tape to once again become neutral.